Okay folks, welcome back. This is part 5 of our Monster Hunt series. So we're getting very much towards the end now. This is our second last part to this particular game, and we're into the update function now. So we're actually going to get some things appearing in our world after this, because this function is all about updating the state of the world. So when things change, that'll be the render function, but this one is updating. So when something changes, what do we want to detect, what's changed, and basically update our world to reflect those changes. So essentially, the changes that are likely to happen here are really caused by our, by our keyboard events that we now have. And our changes are the position of our hero object, so he's constantly changing, and also whether or not the monster has been caught, and therefore do we need to reposition him. So they're essentially the changes that we need to track and to rebuild our world for. So we're going to do this using a series of if blocks. Now firstly, we're using a variable passed into our update function called delta, which is coming from our main function down here, our mainline function for this program, our game, controlling our sort of game, our game loop. And delta is how long has it been since the last time the game was updated, and now. What's that period of time in seconds, so that we can then use that value to kind of control how quickly things might happen. And that's a pretty common technique with canvas-based games, so it's a very normal sort of thing to do. So we're going to use an if statement. Now, what we want to be detecting here is what was the code of the key that was passed from the event that triggered this function, this whole function to run. Okay, what was that key code? Now, we only want to write code to respond to the left, right, up and down arrow keys. So those codes are actually 37, 38, 39, 40. If you think about the keypad, or the arrow-based keypad in a clockwise direction, starting from the left arrow key, the left arrow key is key code 37. And then we go clockwise, which is up is the next one, which is key code 38. Right is key code 39, and the down arrow key is actually key code 40. So we can use some if statements, simple if statements. Oops, not that. Use some simple if statements to detect, have we had one of those key codes pressed. So we'll start with 37, the left arrow key. If the code held in our keys down array is 37, because remember we put that code in there using the event listener. If the value 37 is in our keys down object, then we want the hero.x, the x value, to move to the left. So we minus from our current position, and we're going to use hero.speed, which is a property of our object, our hero object, and we can play around with that and getting moving faster and slower. That's kind of a bit of a trial and error thing. And we're going to multiply that by our delta value, which comes from our mainline function. So that sort of controls how quickly that speed is going to move and how fast that's all going to happen. So that's a pretty normal sort of thing to do, way to do that. And we're basically going to replicate that function for all of our other objects. Only if we're using our other, we just want to change what direction they're moving in. That's the only difference. So if I move around in my clockwise order to my up function, my up arrow key, sorry, which is key code number 38. So key code 38 is now contained in keys down because the up arrow has been held down. When I'm moving up, that's a change in the Y direction. So moving left and right is the X direction. Moving to the left, I'm subtracting. Moving to the right, I'm adding. If I'm moving up, then I'm subtracting from Y, and I'll use the same condition, or sorry, same calculation, hero.speed times delta, to determine how quickly and how much that character is going to move. So I've then got the moving further around in my clockwise direction. I've got the right arrow key, which is key number 39. So players holding down the right key, that's also a change in the X value, moving horizontally, and I'm adding because I'm moving further to the right. And 40 is my final value. So just a simple series of individual if statements that determine which of the keys is pressed and runs a simple command to move my hero object in the relevant direction. That's all I need to do. But I also need to detect when the hero and the monster collide. So when do they have a collision? So if they have a collision, I can detect that reasonably easily and do a couple of simple things. When they collide, I want to add one to the monster's court variable, and I also want to reposition them again. So basically I'm going to run the reset function again. So detecting whether the two objects are touching. This also is a relatively normal thing that you do a lot of the time. It takes a little bit to get your head around this, so you might want to stop and think about how this is kind of working, and I might bring my game in to kind of help explain, I suppose. The reason why the 32 is used is because these characters are 32 pixels by 32 pixels. So that's simply a result of the width or the dimensions in pixels of these objects. So I'm checking, is the hero.x coordinate, is it the same as, is it less than or equal to the monster x coordinate plus 32? So I'm needing to check, is it less than or equal to this point here plus 32? So that's allowing me to detect a collision both on this side, but also a collision on the left-hand side. So that's why that's doing that. That's why that sort of notation is used. It's allowing me to detect collisions on either side, the left or the right-hand side. And I'm also doing the same thing essentially for my y coordinate. So I'm detecting is the hero.y less than or equal to monster.y plus 32, and using a bunch of ands because I want all of those things to be true if I get a collision to be detected. If a collision is detected, and I might provide a resource for you later on collision detection, because there's some really decent explanations online about how that kind of works, and it's something to understand, but it's a pretty much the consistent method all the time for detecting collisions between two objects. If that's true, if this is true, the two objects have collided, I add one to my monsters.caught variable because I've caught another monster, and I run my reset function again to come up here and reposition them, put the hero back in the middle, and randomly assign my monster a new position. And that's pretty much all that's happening in my update function, and that's continually happening right throughout my game as I'm either moving my hero object around the screen using these, and then checking, well, have I caught a monster? And if I have, I'm doing those things. And those things are just happening over and over and over again. And they're continually redrawn using our next function we're going to look at, which is render. So that's where we'll move on to in the last stage.